All right, welcome back. This is lesson 2, part 4. For those of you that are looking in the book and want to figure out where we are, we have just finished up 1.3 and we're about to start 1.4. All right, so we're going to start simplifying some algebraic expressions. We're going to evaluate them, which means we're going to actually solve them. And then we're going to practice translating from English into algebra. I'm also going to discuss degree with you all. So let's get started. All right, so if we have our equations, right? We've got bunches of stuff going on, and we want to figure out how to collect things. We're going to need to look at like terms. All right, so if I have something like this, AB plus AC. As of right now, I cannot combine these. My A is a common factor. I can factor that out. All right. And I have a B plus C. That stays the same. But I can't somehow smush the AB and the AC together beyond what it is right now. They have to be like terms. And one of the things you need to look at with like terms is not just the letters. You need to look at the exponents as well. So if I have an A squared plus A plus 1, I cannot combine these two. There's an addition happening here. I could use subtraction. In either case, we cannot combine those. Now, if we're talking about A squared times A, then we can. All right, that's just the multiplication. That would take us to an A to the third. But if I have something where I am, let's pick a long one here. Let's go 6A plus 5 minus 11A plus 9 and then plus A squared. All right, so at this point, I'm adding them all together. I can only add things that are like terms. And I'm going to point out that my like terms, I'm going to do some colors here. My like terms can be constants, like this. I have my 5 and my 9, right? So 5 plus 9, and that's going to give me a 14. So that much I can collect, all right? And then I'm going to also be able to collect my A's and realize here that I have an exponent of 1 on this A and a 1 on that A. This is an A squared. It is not able to be collected with these A to the first powers, or what we would normally think of as just plain A. All right, so I've got my 6A, and I'm going to keep my sign with my negative sign here with the 11A. So I'm subtracting 11A, and that's going to give me a negative 5A. All right, and then I have my final term that I can work with, which is my A squared. So when I'm all said and done, right, when I've done everything and collecting, and we normally do it from alphabetically with the highest exponent first, all right, that's just convention. I will not mark you wrong if you don't do it that way, but be aware that other instructors may require you to do it that way. All right, so here I've got my A squared. I've got a minus 5A plus 14. And now I've collected everything I can. All right, so in this particular instance, the like terms are not too difficult to spot. When we have more than one variable together, it can be a little more challenging. We can play with some of our different properties and see if we can, kind of reduce things that way. But generally speaking, you've got to be really mindful about both the variable or variables. They have to be exactly the same, raised to the exact same power. All right, so let's just do one real quick, and then I'm going to probably wind up this video and start the next. All right, so I've got, if I have a negative, and let me put a line there just so we're clear, we're starting something new. So negative 6xy plus 4xy. All right, if we stop and think about this, I can factor out my xy out of both of these. So let's go ahead and do that. I'm going to factor out my xy. And when I do that, that's going to leave me with a negative 6 plus 4. Right, because I've already pulled out these xy's in both cases. All right, and now I can actually collect these guys together. And I'm going to have a negative 2 times my xy. I could also have done this directly. I could have said, okay, I have a 6xy, I have a negative 6xy, a positive 4xy. I know those xy's are exactly the same. We don't know what the number is, but we know they're the same because they're both xy. And then I could have collected them directly instead of factoring that out. Either way is correct. I am a big fan of making certain people have more than one way of approaching a problem, so that hopefully it seems a little less daunting. I will wrap this up here with just one more thought. I know we've already talked about the fact that I can have a variable, and if I don't have an exponent on there, it's understood that it's a 1. And we've talked about having an x squared and whatever else, right? So this can become really important. And when we have more than one variable, like in this case, we had the xy, each of those has an exponent of 1. And when you get through adding up all of these exponents on the single term with the highest number of the highest number in the exponent, that's known as the degree of the problem. So degree in this case is 2, right? Because I've got my x and my y. Here I've got a degree of 2. Here I have a degree of 1. And if I have a number, just plain old constant, my degree is 0. All right? My degree would be a 0. My degree here is the 1. Here my degree is 2. So if I have 3a squared b cubed c plus 7a b c to the 4th, right? I'm going to look at these two terms and I'm going to try and figure out what my degree is. Well, here I have a degree of 1. I'm going to put that little reminder there. And you can do that. If it helps you to do it, then do it. All right. Here I have 1 and a 1 on both of those. All right. So here I have 2 plus 3 plus 1 is going to give me 6, right, as my exponent total. And here I've got a 1 plus a 1 plus a 4, and that's also going to give me a 6. So in this case, my degree will be 6. What that tells us is that's the maximum number of times it can cross the x-axis. All right. So in this case, it doesn't say you have to cross it that many times. It says you can cross it that many times. All right. I'm going to stop this here and probably pick up here again in the next video.